All right, so it says place the following in order of increasing radius. There are three sets of three atoms of ions. Don't rank all nine. So basically rank these three, rank these three, rank these three. Increasing radius means smallest first. And there are increasing and decreasing questions on these types of quizzes and tests. So it's really important that we know smallest first or biggest first. So if it says increasing radius, do smallest first. All right, let's take a look at this. So in the first case, we have atoms, and in the second two cases, we have ions. Remember, an ion is an atom with a charge. So if you see charges, you have ions. You rank atoms and ions differently. So let's look at atoms. If we're looking at atoms, we look at this trend on the periodic table. Increasing atomic radius. So the largest atoms are down at the bottom of the periodic table on the left-hand side, and that's because of effective nuclear charge. So as you go across this way and you add more electrons, they actually get smaller, which is counterintuitive because their mass goes up, but their radius goes down because of effective nuclear charge. I'm not going to get into that. I'm just going to go with the trend here. So the trend is increasing atomic radius in this direction. Now we simply need to identify our atoms. So this isn't perfect, but sodium somewhere around there. All right. Cesium is down here, so I'm going to put it like that. All right. And phosphorus is somewhere over here in the same row as sodium. All right, same row as sodium, but way over here. So which of these is going to be the smallest? The one closest to the upper right-hand corner is going to be the smallest. We want smallest first. So phosphorus is less than, because we want increasing order. Less than is this way. Remember, it makes an L kind of shape, so less. All right. So this is less than sodium, which is less than phosphorus. So this is how you do it for atoms. Note that ions are very different. So if you haven't already watched the questions about electron configurations and you're not real familiar with how to do that first. But here we have neon, O2 minus, and F minus. Neon is here. O2 minus is an oxygen with 2 extra electrons, so it's isoelectronic with neon, same electron configuration. F minus is fluorine with an extra electron, so it has 10, so it's isoelectronic with neon. So these things all have the same electron configuration. So instantly you might think, oh, they must all be the same size. But it doesn't work that way because it's not just about electron configuration. It's also about the number of protons. How many protons does neon have? Neon has 10 protons. Simply look at its atomic number. How many does O2 minus have? It has 2 extra electrons, but it still has 8 protons. We didn't change the number of protons when we made the ion. We only changed the number of electrons. And F minus still has 9 protons. So these all have the same electron configuration, but they have different numbers of protons pulling on that electron configuration. Remember that opposites attract. So the more protons you have, the more effectively you can pull on those electrons. Said another way, the smaller the radius will be. So if we look here, all right, this has 10 protons. 10 protons can more effectively pull the electron configuration of neon, making a smaller radius. This only has 8 protons pulling on the same electron configuration, so it's going to be larger. So negative ions are larger than neutral or positive ions, and positive ions are smaller than neutral or negative ions. But in this case we have negative ions. So let's take a look at this. The smallest thing here is actually going to be neon, which is the heaviest. Then it's going to be F minus, then it's going to be O2 minus. So this has 10 protons pulling, this has 9, this has 8. The one with the most protons is going to be the smallest, and we're asked to write the smallest first.